This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Seberg. Good morning, Robert. Good morning, afternoon, evening to all of you, dear listeners, wherever you are. Robert, you're back from traveling, excited traveling.
Yeah, I was in Tel Aviv last week and met with a few startups there. It was a little bit a critical situation, I would call it, but that's another story. Among them, the startup was David. And do you remember David? He was our guest, I think, or I don't know how many episodes.
Yeah, I do recall. Remind us what David does, what you talk with him about.
Yeah, I met him and his company is called Limitless CNC. So really industrial AI, and they are building in CNC agents for chem systems. Very interesting. And the startup has big plans or coming in the next weeks. A new funding round is coming up and we can expect a lot more from them. And I'm really looking forward maybe to record another episode because they do some new topics when it comes to the field of CNC. And when we recorded the episode a few months ago, there was a AI CNC hype. Do you remember a bit? There was every week there was a new startup coming from the CNC area, and now it's a little bit quiet in the area. Maybe.
Oh, is it? Okay.
Yeah, it's like a up and down, I would say. So CNC, very interesting branch and a really truly industrial AI branch, right?
Okay, good. Well, good to have you back safely on the ground.
Yes. I'm really happy.
What did you bring other than?
I bring some other news. I bought something else related to your favorite topic, agents. And it's a little bit a longer story. And greetings to Hans-Michael Krause from Bosch Rexroth. And he sent me something and he worked with Claude Code over the weekend. And now I have the quote for you. So the quote is like this. I built a Python snap that reads live metrics and a PLC variable from the Control X data layer and displays them in a web dashboard. Nothing fancy on the surface, but under the hood, it was already tapping into core elements of Control X operating system ecosystem, like the Control X data layer, the backbone for our open automation platform. Now, the interesting thing, was it smooth sailing? Not exactly. Library dependencies and the early adopter version of Control X kept us debugging for a while, but that's a part of the learning process. My takeaway, Claude Code lowers the barrier to building even for industrial control systems. Is the code perfect? Definitely not. GitHub repo in the comments. I will share the repo. Was it fun? Absolutely. So you see Claude Code or agents and code are coming to the industrial environment. And yeah, it's fun, right? So it's fun and it's not perfect yet, I would say. But we will see a huge change in the whole, let's say, industrial control software area.
Yeah, and I did read this morning, but I didn't get into the details of that one. But we did see, of course, and that is related again to things happening in the bigger world with Anthropic, in disagreement with I think it's officially called the Ministry of War. What a
Department
word!
Of War.
Department of War, I guess. And I think most of us have seen. I think that. With Anthropic saying, we don't want our LLMs to be used for that kind of activity. That's what I saw. And at the same time, I also saw, what is the name of the OpenAI?
They have also an agent approach, right?
Yeah. Competitor product. So, yeah, great to hear that this is happening. If we go back, we can go back a couple of years. And I've received personally so many shitstorms starting maybe 2-3 years ago when this all started. I think in the meantime, that doesn't happen. And I don't think we are saying, that this is perfect today, but we clearly see the path, right, where it's moving, right?
Yeah, right, absolutely. And I would say it's a good result what Hans Michael presented there, because it's right. It's not perfect, but there's a path, as you mentioned, and it's getting better every week. Every week it's getting better. And I had an interesting discussion or exchange with Fabian from Beckhoff. He also told me we should do a session in our event about this topic, because it's a huge topic for them, and we should think about that, but we do that after the recording, because I think it's very important when our listeners say this is a very interesting topic, we should talk about that.
Yeah, sure. You and I need to see if we can still put it into the Alps, or then we do it later on in the autumn version of our
the volcano
in the volcano AI, the volcano. Yeah, right.
AI and the volcano.
Yeah, it's a huge topic. It's a huge topic, and it's so obvious. That's not fair, because I'm still certain that we still have, many. I'm not sure what the share of the listener is going to be to say, yeah, sure, I can see this happening. As Hans Michael says, it's not perfect. You need to be careful. And others will say, okay, then let's look at the long term. And we see that, we can start doing this. And then a month later, you need other people or you yourself to come back and make everything work again. I personally believe that we're going to be solving that, not me, but the companies are taking care of it. Typically the Anthropics and the OpenAIs. But having said that, as you just mentioned, Fabian has been doing this at Beckhoff, 1, 2, 3 years ago. He started right with the team, and they've put a product on the market doing something there. So I'm really very positively thinking about that this is going to be the case. And it's that there was this word in the past, it was this democratization of what? Of technology. So I'm not saying, does that mean, and the question is always going to be, what does that mean for young people and older people maybe changing their job? Because, things are changing strongly in markets. You go from one to the other market and maybe you want to learn something new. What will those people be trained on? Are they going to be trained on the low-level ladder programming? I'm not saying that is not a useful thing to do. But maybe where in the past you had 100 hours of ladder training, maybe today you get an introduction of 10 hours, and you do the 90 hours, you do learning to use tools like Anthropic, OpenAI, or Beckhoff, or Siemens, or any of the other ones. So.
Absolutely. It's very interesting because you mentioned Anthropic, and I think last week they launched something. I think they are coming also when it comes to tabular data in the next few months. They are coming for time series data in the next few months. So there's a lot going on in the whole Anthropic ecosystem, I think. And I think they have a plan what to do. And it's interesting what happens then to the whole, let's say, SAP ecosystem, and what happens to the old companies in the back there, right?
Yeah. I think we kind of discussed it a little bit last time as well, when we say, what's going to happen to the software as a service business.
Yeah, exactly.
Sure. I don't assume, and I'm not using the tools, tell whatever my agent is capable of doing today, build me a new SAP. I guess SAP is too powerful for that. But I can, and the same with all the other ones. Salesforce, I'm not, pointing in on SAP, but just as an example, all the other ones, offering software.
But do you know what is very funny? Because Salesforce is running an agent approach, right, in their software for time series prediction, and they have a model, right? But they choose Kronos, Times FM, and Tyrex, and not their own one. So that's very interesting.
But what is important is that they know that things are changing, right? So that's the only way. It's the only way.
Exactly.
If I see my business model being attacked, and I should be the first one to see it, to have seen it, probably 2 years ago. And to have my people say, what does it mean? In 2 years, our business model is going to be attacked. What are we going to do?
Only the paranoids survive.
Oh, wow. Yeah, a famous quote from Andy Grove. Only the paranoids survive. Right. I have only one news and then 2, 3 more theoretical considerations. I saw that
Oh.
yeah. That's
Oh.
not,
That sounds like a
no,
long,
no, no,
long
no. It's going to be
discussion.
very short. I saw BMW started using humanoid robots. Well, humanoid
Right.
question, I come to that, in their Leipzig factory. Now, of course, we had seen that they had started maybe like 6 months ago with figure robots, right, in Spartanburg,
With figure.
which happens to be BMW's biggest plant globally, I believe, right? And now they have, I would call them rolling robots, humanoids, by Hexagon Robotics. You probably know them. You are a robotics guy. And they shall be used to take over, I understand, unpleasant, repeatable, maybe dangerous work from the humans. Now, as I saw them, the number one thing that I saw was the fact that they roll. So they have small wheels, right? So, and then I was thinking, well, and from there up, they look like maybe a little bit like humanoids, but you and I, we don't have wheels under our
Normally not.
feet, right? So I thought it was like, yeah, you take a typical industrial, 2-arm robot and you put it on an AGV, for example, and that's how you arrive at this. So you tell me, you share with us, because you follow this robotics market very closely.
I think that's the most proper way to
Is
do
it?
it.
Oh,
I
yeah.
think so. So doing legs and steps is very difficult, and there's no benefit, right, in the industrial setting to have legs, right? So if you have enough space that you can use wheels and you can drive through the factories, it absolutely doesn't make sense to have legs, from my point of view, because it's more difficult than you need more power to control these legs. It's very difficult to handle this. And I was a little bit surprised that they are now focusing on wheels. So it's a EV plant, I think, in Leipzig. But it's normal, right? The big corporates are looking what's going on in the market. We try out some figures. We try out these guys with the wheels. And maybe next time we see something from Agile or we see something from Neura, I don't know. And I think everybody's looking what really works at the end. And I think wheels is a good opportunity.
Yeah, but the ones that I see, and I'm not as strongly into it as you, but then, and we always have to be careful that we're inside of our own bubble, of course, but all the announcements I see, like 10, 20, 30, 40 every day, and I hadn't seen one so explicitly with wheels, I must say. So the ones that the big hype, and my feeling is that
you want to raise a lot of money, right? So you have to show. You have to give the VCs a fantasy, right? So, and the fantasy is a running humanoid, right?
Yeah, but my feeling is that if I would be part of the VC, and then we being here in the European, Central Europe, and then every day you see, come to Zurich, there's 100 companies, and then we know from come to Munich, there's 100 companies. Oh, don't forget Paris, there's 100 companies. So it seems that we have 300 companies only in the center, and then, as you said last time, don't forget the companies in the Eastern markets like Poland, other countries. So it seems we have already 400 or 500 of these typical humanoids, so the ones that are capable of really like walking, more or less walking. And if I'm a VC, I think, well, am I going to, dare I say it? I'm not a VC. I'll keep it here. What do you think? I mean, are there already many, so to say?
Many what?
Many of these driving for humanoid walking kind of robots.
I think every humanoid company has also a wheel option, right?
Oh,
so everybody
that's right.
there you
go.
I think everybody's working also on a wheel option.
Oh, damn. No,
but imagine when it comes to households, wheels are difficult, right? So, but from
you need a big house.
You
need a big house.
Castle, maybe, or chateau.
Yeah, it's the only place where I've seen a robot 2 years ago, and it's related to beer. There's going to be another. Peter always talks about beer. And it is in one of these brewery outlets here in the center of town, Marienplatz. Those of you visiting Munich for
This is
touristic
the service
purpose.
robotics
And
stuff.
it's
right?
very long until you get into the very inside. So there's one person staying outside and just punching in the orders, and then this, which is I think is it a Japanese, Chinese? I don't know. And it's
Chinese.
on
It's a
wheels.
cat.
It's like you place the beer on it, and it drives from the center or from the back to the front. That's the only one that I've seen in a, let's say, more retail market kind of environment. And as you say, I mean, wheels in a private house, yeah, you need a castle, I guess.
Yeah, in the castle. Okay, Peter, what else do you have?
Yeah. So two more theoretical thoughts. One is sharing this thought of the AI as an actor rather than a tool, posed by Thierry Rich. So he compares inventions like the printing press. We recall Gutenberg, Mainz, 15th century. And one side notice here, as a Dutch, I owe not a caravan, as Germans will say. All Dutch people have caravans, right, blocking the German motorway. But I have US acronym an RV, which is not the size of the one on the opening scene of Breaking Bad, but something similar. That is from Mainz, but that was just a side note. There's the weaving machine, the Luddites, 19th century, the computer, 20. So there's these three big inventions, and they're like centuries apart, right? And he says they all eliminated specific tasks. Ultimately, they functioned as tools that simply shifted human labor into new higher level disciplines. And he says this time it's different. So the spreadsheet, Excel, it changed how the financial analysts work. The agent, we're back to agents, sure, does the financial analysis. So my perspective on this thing, and I do want to share that I have been saying, for probably 10 years, and always had in my brain this thinking that, yes, I mean, AI is a tool in the hands of a human, right? And I've always questioned the word autonomy, as in autonomous machines, as, a human always needs to push a button before then the system can be put into a autonomous state, right? Now, with agent capability, I must say, thinking about the algorithm taking the place of what in the past was a human, the travel agent is the example, right? There was a human, and I don't know if they still exist today, but at least in the past, they would sit somewhere in a place somewhere in town, and you would go there and you would tell the agent where you wanted to travel, and that was the job of that person. Now, it feels to me that maybe, yes, as we move to the agent concept, the term tool does not represent the technology anymore, as it maybe did with the printing press, weaving machine, computer. Having said that, though, maybe that's how the people felt at that time as well, right? That's why we had the Luddites, people destroying the weaving machines. So what am I saying? Maybe I'm not saying something else, that we all feel that this technology is developing so rapidly, so strongly, that I would almost, if you and I would have, written the book that we did, started 6 years ago, if we would do it now again, would I still, talk about the concept as AI as a tool, or would I go a bit further and say, well, it has moved a little bit further than the tool?
Oh, okay. Interesting. What else do you have?
There you go, which is an extension very quickly, really, of this thought of the actor versus the tool, because Demis Hassabis, which I really enjoy listening all the time, whenever he goes around, he was traveling as well, right? Co-founder, CEO, Google DeepMind. He defined a test for AGI, right? And he says, train AI on all human knowledge, cut it off 1911, and then see if it independently discovers general relativity, like Einstein did in 1915. That's his proposal. And I have a final thought, which is by difficult name, Shamat Palihapitiya, former Facebook VP. This is people who invented refrigeration, made some money. Most of the money was made by Coca-Cola, who used refrigeration to build an empire. Now, LLMs, he says, they are like refrigeration, right? The technology. And the Coca-Cola has yet to be built. Now, while I leave you and the listeners with this thought, I think it's a very powerful thought. I'm not sure it's his own, but I saw it somewhere by him. Let me share a number of key milestones. They were provided to me by Gemini, which I like using a lot, in the development of the refrigerator. And let's think of them as LLM developments. Now, LLMs, we get developments weekly, daily, every hour. Now, the developments of the refrigerator, they were a little bit different. 1748, there's William Cullen. He shows evaporating liquid. Then almost 50 years later, Oliver Evans, it's vapor instead of liquid. There's another one, Jacob Perkins, vapor compression. And then 1876 is a German guy, Carl von Linde, very good. You know, and I was going to suggest he has a patent on liquefying gas. You know, there's a couple of other names, including, again, the one of Albert Einstein. He did something later on as well. Now, when you ask people here, as you already gave the answer, so to say, before I asked, the people here around us here who invented refrigeration, they will always call out the name Linde. Now, Linde, Carl von Linde, his refrigeration produced ice for breweries, allowing beer to be produced even in summer. There you go again, Peter and beer. Now, 100 years later, so we have both, on one hand, Linde PLC, the big company, and there's a couple of other ones, right? Other refrigeration or gases companies. We have those. And we have the Coca-Colas and the beer breweries, right? Now, so that is the starting thought. Now, with the meteorological spring already started, just a day or two back, and the astronomical spring, up in the next couple of weeks, opening of the beer gardens. I'll leave you with the question, or maybe we can quickly discuss it as well, who will be the ultimate refrigeration LLM company? So, we discussed them, the OpenAIs and
Anthropic, Gemini,
etc., or the NXAIs and the XAIs and everybody else on one hand, and who will be the Coca-Cola or Augustiner, Heineken, Budweiser, or other cold liquid brands, companies applying the technology. I thought it was a very powerful thought, yeah.
Absolutely. So you have also a market for specialized refrigerator, right? So when it comes to medical issues, when it comes to pharmaceuticals, so you need very specialized refrigerators for specialized operation. And we will see the same when it comes to large language models. We will see very, 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 very small large language models, maybe in the car. We will see big refrigerators for for use cases. And it's an interesting discussion, yeah. And who's producing Coca-Cola and Heineken beer? Let's see, yeah.
Right. And the the potential behind that question is exactly that. I mean, even, so it is like, Coca-Cola, Augustiner, Heineken, Budweiser, they did not invent the base technology for the capability to build what they build. And I think that's a very strong, powerful, and of course...
But they started brewing beer before the refrigerator, right?
Yeah, they did. And that's coming back to the beer gardens. As you know, that's why in our beer gardens we have the very specific trees. Don't have the name at hand right now, but they were chosen as the trees that give the most shadow, so they could put their beer in the beer gardens and keep it as long as possible cool. But yeah, that was the thought, of course, and it's not exclusively for Europe. It's always like, oh, the Europeans, they don't know what they're doing. We do know that we have.
And at the end, one question, Peter, because a refrigerator is now a commodity, right? Every household in the Western world, or maybe more than it was, has a refrigerator now. So it's a common product at the end. Everybody can use it. Every child knows how to use a refrigerator, right? But it's still a secret how to produce Coca-Cola.
Interesting thought. The first one immediately comes to my brain, yes, and I'm completely convinced that all of us are going to have our personal assistant one way or the other. I'm not going to know, but then I'm still convinced it's going to be on this little thing that lies in front of me called handy or smartphone. It could be something different. And yes, there's going to be some kind of LLM on it. And there's going to be brands, like the refrigerator brands. Each of us are going to choose one of them for not purposes of, well, maybe one that is like energy consumption. That could be. The other one, more importantly, I believe, is like the type of answers we will get, or the type of things it can do, and the type of answers we get. Answers are very political, or let's say cultural. Who am I as a person, and what kind of answers do I expect or would like to have? But that's a very good thought. And then you say the other thing, you say the recipe. Yeah, sure. But then, and if I may answer that one, if let's look at the big automation companies. That's one. And then secondly, there's potentially, of course, other kinds. So the first one is the incumbents. So they are the Beckhoffs and the Siemens and the Rockwells and all the other big automation companies. And they have a lot of patents, a lot of secrets, which they can't just open. Although at the same time, having said that, we're using a lot more open source technology these days as well. And secondly, as I say, there is always a potential for a company that comes in from the side, that has not been an automation company and does everything completely new.
Let's see
who it's going to be. If it's a combination of any of those.
Perfect, Peter. So let's switch to the main part. And we already talked about robotics and humanoids. And I recorded an episode with a wonderful name, Leonardo Barcelona from University of Amsterdam. You know Leonardo?
Right.
And we talked about the digital cousin, because there was a huge discussion at our event AI in Amsterdam about the digital cousin. And I thought, we should record 15 minutes, 20 minutes about the digital cousin. What is the digital cousin? And why is it so important when it comes to AI and robotics? And Leonardo explained us their approach in Amsterdam.
Looking forward to Leonardo, not from the Italian town Vinci,
no,
also not from Barcelona, I believe, but that is his family name, right?
It's his family name, but he's from Italy,
yes, yeah.
But he has a very nice name, Leonardo Barcelona. I really like it.
Wonderful.
Thanks, Peter. It was a pleasure, as always.
Robert, thank you very much. See you soon. Take care. Bye-bye.
Keep your Coca-Cola cold, right?
Exactly. Or
your beer.
Augustina cold.
Or your beer. Bye.
Take
Bye-bye.
care. Oh, we're not being paid for this by Augustina, by the way.
That's very important. Bye.
Take care. Bye-bye.
My name is Robert Weber, and my guest today is Leonardo Barcelona from University of Amsterdam. Leonardo, welcome to the podcast.
Thank you. Hi, Robert. Thank you. It's a pleasure and honor to be here.
Yeah, Leonardo, it's an honor to host you here in the podcast, because we met 2 weeks ago. And before we start talking about the digital cousin, I'm really looking forward to the digital cousin. Please introduce yourself briefly to the listeners.
Yeah, so I'm Leonardo Barcelona. I'm currently a researcher at the University of Amsterdam. I mainly work in robotics and robot learning. Particularly, I work with reward models right now, trying to create this representation for robots to learn how to interact with the world.
Let's talk about the digital cousin. I'm familiar with the digital twin, but what is the difference between the cousin and the twin?
So the digital twin is well known. I think you try to create this replica for the environment. You try to perfectly mimic the environment or the aspect. For robotics, it means basically you try to create a 3D representation with the physics simulation inside. While instead for a digital cousin, you don't try to create a perfect replica per se, but you try to create a similar replica, something that is resemble the physics aspect, the shape, the appearance of the environment, but is not exactly copying all the aspects. So you don't expect the digital cousin to be exactly the same as a digital twin.
But why is it important? Because if you have a digital twin, why do you still need a digital cousin?
So the idea of digital cousin is quite recent. In 2024, a very interesting paper that among the authors have Fei Li, that is a very famous researcher in the area. So in this paper, they show that using just a digital twin, you can train a policy, but this policy is not as robust as training the policy with the digital cousins. So like the idea to have something that is not exactly matching the environment is still helping to create a model that is more robust.
Ah, that's interesting. So if you work with a digital cousin, the model gets more robust, or am I wrong?
Yeah, so the idea is that like you try to like the idea is that you can use a digital twin, but if you want to generalize more, as soon as you have some differences between the train environment and the test environment, the policy will drop the performance. Instead, when you have digital cousins, you are practically pushing the policy to generalize better, to like the policy is not expecting the exact same environment, but it has seen more variations inside, so it has seen more type of objects to interact with. Another aspect that is very important is that you can have just one digital twin, so ideally you have just one perfect replica. Obviously that is utopic, you can't have it in a practical way, but instead, with digital cousins, you can also variate among them. So they also show in the paper that you can generate many versions of similar replicas of the environment, not just one. And also this is increasing the performance as well, because you are generating much more data. You are increasing a lot your distribution.
Can you explain us, or can you give us an example when it comes to robotics and a digital cousin? How does that work at the end?
So let's take a very, very simple example. So you have a table, you have a robot, and you have a cup. So if you want to create a digital twin, you want a perfect replica of your table, a perfect replica of your cup, and a perfect replica of your robot. And then you can train your policy inside this simulation. You have the physics parameters as well. You train a policy on it, and you deploy in the real world. With a digital cousin, instead of creating the perfect replica, you may have like a table, but still this table maybe is a bit higher, is a bit maybe lower. It has a different texture, so the color of the table is different. Maybe the cup has different physical parameters. Maybe it has an handle that is not present in the real world, or vice versa. And so you're training the robot with this simulation that is not exactly matching the real world, but is very close. And then you execute the policy in the real world. And in the real world, basically you have the cup that was not really the one in the training set, but actually your policy is performing better.
So it's more robust at the end.
Yes.
So what is the baseline, or what is the basis for the digital cousin? Is it a digital twin, or is it possible to train also a digital cousin? Or do you need first to train a twin?
The idea is that actually you never go through a digital twin. Like you start directly from a digital cousin. So for example, you can use retrieval or generation, and you can try to take some assets from maybe a library of available assets, and you just place them inside the simulation. So you don't per se need to start from a digital twin. On the contrary, actually, like you start from a digital cousin, and we believe that in Amsterdam, like we are working on world models, and we are trying also to all these terms, all these aspects are connected. But our idea is that if you start from a digital cousin, you can get closer to a digital twin during execution. So if you can update your simulation, if you can update your digital cousin, you start from something that is different, and you get closer and closer to a digital twin.
Okay, so the digital twin is still important, or am I wrong?
Yeah, the digital twin is very, very important because you don't start from scratch. So it basically helps you to have a policy that is not really starting, like you don't have to wait for a day before applying your policy, but you can really start deploying your policy. And as the policy is going on, maybe you can start updating this representation, and then basically you get closer to the digital twin. So it's basically the digital cousin, in our view, is like the starting point to create the replica, the representation for their digital twin, and to enable basically the robot to reason on the environment itself.
So when it comes to industrial applications, and robotics for sure is an industrial application, but when I talk to the guys in the industry, everybody's doing now a digital twin of every component in the factory. Is this the wrong approach?
I don't think it's the wrong approach. On the contrary, I think it's very, very important, because if you remember that, like, to have a digital cousin, you need the starting point. And if you have some digital twin in the past, you can leverage the past knowledge, so the past models, to create your digital cousin. So indeed, I believe that digital twins are basically one of the final goals. This is something when you have a new process, when you want to generalize better and you don't have the time to prepare a digital twin, you can still start from something similar. So you can still try to arrange what you already knew in a way that is helpful for this task, for this new task. So indeed, like, it's helping in generalizing better. It's helping in avoiding to wait before really starting to produce. So indeed, I think this is complementary. It's not really, they go together, as said.
Can you please share in a few sentences which role the cousin plays in your world models and how the robotics is playing into this?
So let's start from one to point out something. So first of all, like, so far, most of the digital twins, they are not perfect replica of the real process of the real environment. Particularly when you have robotics, you don't have in general perfect replicas as physical parameters, all the possible aspects. I mean, like, in a general setting, not in an industrial scenario. If we think about in the future to a robot that is interacting with the unstructured world, you can't have like the full observation of the world. You can't have all the possible physical parameters of the object directly. So in this view, the digital twin is where you start. So basically, your robot is kind of trying to remember past assets, past objects, and after this step is trying to place these assets inside the simulation to start learning and reasoning on top. So as I was mentioning, like, we have this example with the table and the cup. Now, if we think wider example, maybe the robot enter a new room in a new environment. So we have a mobile robot is entering a new room. It doesn't know exactly what's inside the room, but maybe he's seen some kind of table and is recalling that in the past it has seen a similar table. It sees a library and is recalling to have seen a similar library. And after this step, it can start exploring the environment, start maybe also directly perform the task. And while executing the task, while interacting with the environment, the idea is that we start updating also this representation. So this is also connected to the trend in world models in some sense.
Mm-hmm. Okay. So let's come back to the digital cousin. Is it still a research topic, or do you see already digital cousins out there?
I believe actually that is more a research topic right now. I think it has strong potential to become very important in the future, but right now there are not many papers tackling this aspect. Even if, like, the recent trend in real to sim to real, that is also quite close, it's basically, if you don't have a perfect transportation from the real world to the simulation, this is actually a digital cousin. So if you, for example, reconstruct an object, but the reconstruction is not perfectly matching the original object, you don't have really a digital twin, but you have a digital cousin. It's just that people maybe, like, you usually don't really look into these details when you probably implement these kind of pipelines.
So, Leonardo, thanks a lot. At the end, one more question. What is on your research agenda in the next few months?
We have a lot of going on research in Amsterdam. Right now, we are trying to deploy VLAs with this kind of idea of real to sim to real world models or automatic digital twin creations.
Automatic digital twin creation, what is that?
Basically, it's the idea that, like, in our view, like, a world model could be also seeing as a digital twin, but it has to be automatically created. So if you can automatically create your digital twin, basically this is your world model. So the robot can basically create this simulation automatically, and it can learn inside the simulation and then act in the real world. So currently in our group, we are trying to take these huge models, these VLAs, and we are trying to train them inside these digital twins that are automatically reconstructed with the aim of improving robustness and improving the accuracy of the execution.
Leonardo, thanks a lot for the explanation of the digital cousin. It was a pleasure. Greetings to Amsterdam.
Thank you a lot. It was a pleasure from my side to talk about this topic.
Thanks.